Good evening and welcome. Let's test out the desktop sound.
Hello, Maurieo! Morris O'Neill here, also known as Maurieo. Got my contact details there, so if you want to contact me, perhaps you'd like me to make a small video about what a problem you're having, be it relation to surveying, maths, or anything really, I'll have a go. If I know, I'll certainly give it a go. Regarding my photograph there, that's me in 1972. I've changed a bit since then, so I'm not hoping to raise your expectations there. So let's hope that sometime soon you click on a video and you hear, "Hello, Maurieo!"
I'm reasonably satisfied that everything's okay, so let's get underway. And first up, all right, Mario's 10 questions about the periodic table. Okay. The modern periodic table is arranged by increasing atomic number. Good evening, Moz 42 from far north Queensland. Not atomic mass, thanks to Henry Moseley's work in 1913. The periodic table. Well, I think it's correct in terms of atomic number. The only areas of doubt here are Henry Moseley, who I think there was a Moseley that was involved in the Communist or Nazi Party in Britain during World War II and 1913. So I'm going to go with true, but there is some areas for potential errors here. But yes, I'm with T for true on this one. It's definitely atomic number. Hydrogen has one atom, I think, or H2. Hydrogen is the first one, isn't it? I don't know what the next number on the periodic table is. Hydrogen. I think oxygen is at 8. I'm not sure. True. Moz says true as well, so we'll go with T for true. And let's see if we can get through without confusing grok tonight. Yes. Periodic table. That's correct. Dmitry Mendelev's 1869 table was ordered by atomic mass, with some swaps for properties. Henry Moseley's X-ray spectrophy 1913 showed elements should be ordered by atomic number of protons, resolving inconsistencies and confirming the modern structure. Well, good old Henry Moseley. Thank you, Henry. We'll move on to the next question. Question 2. Second is helium. Yes. Hydrogen, helium. I think there's a mnemonic for remembering the periodic table. Unobtainium. There are currently 118 confirmed elements on the periodic table, with the most recent additions nihonium, moscovium, tennessium, and organessium, officially named in 2016. Lithium. Oh, Mars is a, yes. Hydrogen, helium, lithium. Are they the noble gases? What are the noble gases? Yeah, helium. Atomic number 2. Lithium. Ooh. All right. Oh, we've got a periodic table. The super heavies are waiting. All right, they would be super heavy. So, yes, most recent, Nionium, Moscovium, Tenesian, and Organessian. Okay. True, but not sure. Yes. Always that potential. Deaf true. Yes, I couldn't argue with that logic, Moz. 2016 was a good year, though. It was a good year, 2016. Correct. As of January 2026, there are exactly 118 confirmed elements. The 4 super heavy elements, NH, MC, TS, and OG, were discovered between 2003 and 2010, officially recognized by the IUPAC in 2015, named on 28th November 2016. No new elements have been conserved since. How does one find a new element? Obviously, atomic number. Yeah, have to find them in order, I guess. Right. Yeah, because have they got every? I suppose they've got every number. We're about to find out, I think. Sorry, that number's taken. I think they'd be able to predict. The periodic table was first published in its modern form by Dmitry Mendeleev in 1869, and he left gaps for undiscovered elements, correctly predicting their properties. Well, I don't think that's true, because Mendeleev did his one on atomic mass as per question 1. So I'm calling false on this one. Its modern form was not till 1913 when Moseley did it on atomic number. But Moz says true, so we'll go with true. Okay, I'm just putting my point of view there. Please be a fart. Oh, yes. Try not to try not to get into the speaker. Oh, that's come back at question 2. We've done question 3. Oh, what have I done? Did I push the wrong button? Focus. Focus. And we're going T for true on that one. We'll see what happens. It's coming round. It's a heartache. Here we go. I can feel it. Correct. Mendeleev published his first table in the 6th of March, 1869. He deliberately left gaps for Eka aluminum, gallium, discovered in 1875, Eka silicone, germanium, discovered in 1886, and predicted their properties with remarkable accuracy, including atomic weight, density, and reactivity. This was one of the strongest proofs of his system. Okay. All right, 3 from 3 as we go now carefully. N for next. Okay. Question 4. 3 from 3 on the periodic table. Okay, and what do we have? What do we have here? What's happening on the periodic? The lanthanides and actinides were placed in the main body of the periodic table between groups 2 and 3. What the hell are you talking about? I've got no idea. I understand the periodic table, but I'm not familiar with the grouping. Yeah. But, yeah, I could neither confirm nor deny that. If my life depended on it, I would say true and hope for the best. But the lanthanides and the actinides, not sure. False. Moz says false. Okay. 'Tis done. 'Tis done. Do you know what you're talking about, Moz? True or false? We'll see. We're orbiting the F block. All right. No. Must be true. It's correct. The lanthanides, elements 58 to 71, and the actinides, 90 to 103, are the F block elements. They are not placed in the main body, which would make the table extremely wide. Instead, they are usually shown as separate rows below the main table, with a placeholder between groups 2 and 3. Groups 3B in older numbering. This convention keeps the table compact and readable. Well, there you go. Sounds right, you're a bloody genius, Moz. Yes, oh well, who knew? Yeah, obviously there's more to the periodic table than meets the eye. N for next. Okay. I see they're going to ban X in Australia for showing your prime minister in a bikini. Group 18, the noble gases, are called inert gases because they have completely filled electron shells and do not form compounds under normal conditions. Certainly there are the noble gases, and they're also inert. Yeah, I'm going true. I'm just loose though. I don't know about the completely filled electron shells, but that would explain them not forming compounds, I guess, because they got nothing spare. Like there's no helium oxide. True and true about X. PM is a wimp. Yes, but does he wear a bikini? T for true. Mr. Albanese. What? This is going a bit weird. Hang on. We just that's right. Oh, there we go. Group 18 elements: helium, helium, neon, argon, krypton, xenon, and what Rn is. Anyway, have full valence shells, octet rule satisfied, making them extremely stable and unreactive. Hence the old name, inert gases. They were thought completely unreactive until 1962, when Neil Bartlett synthesized the first compound, XPTF6. Now we know xenon, krypton, and radon form compounds, but under normal conditions, room temperature and pressure, they still do not react. The name noble gases is preferred today. 5 from 5, the noble gases. Next. For next, not for noble gases. Radon, okay. Oh, right. Good. Albokini, yeah. Question 6. The element with the highest electronegativity on the periodic table is fluorine, which has a value of 3.98 on the Pauling scale. 3.98. That seems a bit high. He says knowing absolutely nothing about the Pauling scale. That's appalling. The element with the highest electronegativity on the periodic table. Fluorine. Fluorine gets a pretty bad rap, but it's 3.98 on the Pauling scale. I must try and get that into conversation next time someone's talking about fluorine or fluoride. I'd say, but yes, you must remember, of course, that it is 3.98 on the Pauling scale. And they say, oh, what's the Pauling scale? Well, that's appalling. You don't know that. Dear me. The Pauling scale. fluorine or fluoride. Put it in your water. Aren't they putting it in your bread? What's the one they're going to put in the bread? Fluoride. No. There's something they're going to put in the bread. True, Moz says. True for that. T for true. All right. Wow, we're 5 from 5, so we're doing pretty good. And we've got one false in there. So we've picked the false one in the first half of the quiz. We move on now. True, correct. Fluorine holds the record for the highest electronegativity at 3.98 on the Pauling scale, the most widely used. Cesium, 0.79, and francium, approximately 0.7, are the least electronegative. Electronegativity increases across a period and decreases down a group. Oh. So there's periods and groups of the what? What the hell? Okay. In terms of the periodic scale, briefly, explain groups and periods. Okay, what's going on here? Move the sidebar. So this is here. So what's going on? Groups are the vertical columns, top to bottom. Elements in the same group have the same number of valence outer shell electrons, so they tend to have similar chemical properties. Group 1 alkali metals are all very reactive. Periods are the horizontal, the rows. Elements in the same period have the same number of electron shells, energy levels. As you move across a period, the number of protons increases and properties change in a regular way. Metals, metalloids, non-metals. Oh, there you go. I didn't know that. Right. Okay. Well, that's yeah. Okay. Periods and groups. There you go. Yes. Oh, well done, Moz. Okay, let's go for the next. I should have known that. Oh, this is all part of your metallurgy studies, I guess. Is it? Elements in the same group, vertical columns, have the same number of valence electrons and similar chemical properties. All right. Yes. Oh, well. There we go. There we go. I think we can say yes to that one. I sort of predicted that. Okay. It was a bit of an obvious question, I guess. All right. I think that'd be true. Yeast. What? What's the yeast comment about? Yes. I'm not following that yeast comment. Where did that come from? Was it something I said? That's correct. Elements in the same group share the same number of valence electrons, outer shell electrons. That's why they have similar chemical behavior. For group 1, alkali metals all have one valence electron and react vigorously with water. Group 17, halogens, have 7 and form ions easily. Oh, no. Oh, okay. No, there's a mineral or something. That they propose to put in bread. No, there's something like fluoride that they've been proposing to put in bread, or they put in bread in some countries to inoculate the population against, for something. Can't think. Right, question 7. Right, next. Yeah. No, they've talked about it. I've heard people talk about it. Iodine. Oh, right. Folic acid. That's the one. It's folic acid. Yeah. Mandatory from 2023 in New Zealand for bread making flour. Folic acid. Vitamin B. Yeah, they put folic acid in the bread in New Zealand. Except organic bread. Okay. The periodic table is divided into four blocks: S block, P block, D block, and F block, based on the subshell being filled in the atom's ground state. Well, they have talked about the blocks. I'm not sure. Sorry, sourdough, not Bambi. They use vinegar to make fake sourdough bread. Oh, okay. All right. Yes. No. It's something. It is. Yeah. The big reasons for folic acid in bread are. I'll put it up here. Timing. The neutral tube closes very early in pregnancy, so supplements only help it taken before conception and in early pregnancy. Reduces neural tube defects like spina bifida and anencephaly. Coverage. Lots of pregnancies are unplanned and supplement use isn't consistent. Fortifying a staple food helps more people get protective levels. Help groups with higher NTD. All right. Evidence. Countries that fortified flour like Australia. Okay, it's also in Australia as well, apparently. Folic acid. Okay, yeah. Sourdough, not Bambi. All right. Right, so what have we got? Question 8. Is this true? I think true. Yeah. Question 8, I believe that to be true. There is definitely blocks. And whether that's, yes, teeth true. Yeah, folic acid is the one I was thinking of, and it's, yeah, to help prevent spina bifida in children. But it looks like it's also invalid. Correct. The 4 blocks respond to subshells being filled in the valence shell. S block, P block, D block, and F block. All right. So there's more to this periodic table than meets the eye. Okay. I'm sure they probably said that once at school, but I never took much notice of it. Intriguing. They've put a lot of thought into it, haven't they? Right. Technetium, atomic number 43, and promethium, atomic number 61, are the only two elements in the periodic table with no stable isotopes. Well, is this true or false? Got no idea. Promethium and technetium. Promethium and technetium. What do you weigh? When I went to school, we had a block, B block, C block, and D block, which made up the buildings. Yeah, well, we had H block as well, which was shaped like an H. it had two. It was a two-story. They were actually called Nelson blocks because they were made in Nelson. They were designed in Nelson, but it was shaped like an H, and it was H block. Yes, but we had A block was the administration block, B block, C block, D, E, F, G, H. I think we even went up to J. I think at one stage I was in 4J1, which was a prefab in J block. Yeah. I was thinking that too. H block. I think H block. Yeah, I think it's true. Yeah. J. I don't know if they had K and L. No, I think J might have been the maximum. Oh, it's true. All elements up to bismuth 83 have at least one stable isotope, except technetium 43 and promethium 61, which only radioactive isotopes. Tc is the lightest element with no stable form and is completely synthetic on Earth. Pm is also entirely radioactive. No other elements in the table share the distinction. 9 out of 9. And we go to question 10. We could be looking at a perfect score here. If only we can get question 10. Okay. We wait. The folic acid. Our PM is radioactive. Are there any isotopes? Right. What happened there? N. We want the next one. Does he form isotopes? Who was the last Prime Minister of Australia that you had any time or respect for? You know, going backwards. Here's the final question. The International Union of Pure and Applied Chemistry is the organization responsible for approving new element names and symbols. The IUPAC. No, I'd say that is true, but yeah, I would go true with that, but it could be wrong. It could be the International Unit, the International Organization for approving new element names and symbols. But I wouldn't know. Malcolm Fraser. Okay, yeah. Right. Malcolm. Yeah, he's still around too, isn't he? All right. Malcolm Fraser. Oh. Yeah. I can remember him. Yeah. Explain IPAC's naming process. True. We're going T for true. So we're getting into. Oh, good Lord. Okay. Here we go. Well, T for true. And true for T. Correct. IPAC is the global IUPAC. UPAC is the global authority for chemistry nomenclature, including the official naming and symbol approval for new elements. After discovery and verification, the discoverers propose names, but IUPAC reviews, approves, and announces them, e.g. the 2016 naming of elements 113, 15, 17, and 18. Oh, okay, but 14 must have already been known. Right, well, there we go. 10 out of 10. A flawless performance. You conquered Moseley's atomic number revolution, the 118 confirmed elements, Mendelev's prophetic gaps, F-block placement, noble gas stability, fluorine's electronegativity, crown group valence similarity, the 4 blocks, TC's PM's invisibility, and IUPAC's naming power. No gaps, no errors. Bloody marvellous. This has been Maurieo's 10 questions about the periodic table. And now, let's get on with the show. Some memes from far north Queensland. First up, we've done the T-Rex. If they awarded my sarcasm, yeah, look at all those. Right, yes. Yes. Yeah, now this is oh, here it is. This is the one I was where are oh, this one. Oh, yeah. This one, yeah. Okay. Oh, make that bigger. Okay. Okay, and this one here. So here's the guys from South Korea. Look at that. This guy's he's got so many medals. He has to put them on his trousers. Look at these poor guys back here. But wow, look at all those campaigns that they've been in. Holy shit. These guys know medals. That's what you call a medal. God knows what they got theirs for. Right, and now. I was at the cemetery today laying some flowers down. As soon as I began to walk away, a lady came up to me and said, "Hey, how are you today?" I replied, "Oh, shit. Can you see me?" She was freaked out and ran off. Dime a dozen for medals. Yeah, I don't know. Oh, they're all campaign. I bet. Yes. Now, next one. Here we go. I asked myself if I was crazy. We both said no. About right. A dime. Yes, Aaron. These go well with pasta. These will kill you. Okay. Oh, the guy's got slightly different, got his thumb on that, and yeah. Spot the difference. I want one of those patches. Well, I don't know where you get them from. Tactical Gear Junkie. Customer made. Make your own custom text patches at tacticalgearjunkie.com. Okay. Can we get them there? There we go. Okay. All right. Yeah. Okay. So there's all sorts of yep. Tally ho. Tally ho, retards. Oh my God. Oh, these are all the different ones. You had me. We'll make it look like an accident. Yes. Okay. All right. What else have they? Anything else? No. Yeah. So, what can you do with these? Angry. IDFC bear. Right. All sorts there. What's this one? My pronouns are. Let me see them titties. Right. There we go. Yes. There's quite a few there that you might tickle your fancy. Custom ones. Right. Oh well. Design your own. There you go. Pricing. All right. Got that one done. And we got the mushrooms. And finally, when you ride along enough, nap time is part of the adventure. Right. I was watching a little story on today on YouTube, and they were on a site, and I was listening to one story, and I fell asleep in the middle of it, and I woke up in the middle of another one, and it was about 2 hours later. So I listened to the end of the other one, got the gist of that. Then I had to go back to the first one I was watching to finish that off, and there was another one in the bloody middle. So yeah, oh well. Right. Okay. I've got. Okay. Oh, I've got one. I'll do two. I'll do two, just to finish off. Follow the link. There we go. Masturbation hurts. Edward Scissorhands. Oh dear. Never mind. And I said two, didn't I? So we've done that one there from there. That one was from, that was from Joker's Whale, was it? Was that the one I just did? I think it might have been. Oh, there it is again. It still stays the same thing. Hasn't changed. And this one here from Smart House Brunette, which I think I might have. All right. Nobody working 40 hours a week should be living in poverty, Bernie Sanders. Then stop giving their money to people working 0 hours a week. Edward was Jewish. Eventually. Yes. Oh, no. We need one more. One more. And that's Smart Ass Brunette. Who's this one from? Mrs. S. All right. Let's see if this is a suitable one to end on. Okay. Here we go. Wife, grow up. You can't believe everything you read on the internet. Me. I don't need this. There are local singles in my area dying to meet me. Yes. Too true, too true. Okay. Yes. All right. This has been a Maurieo presentation recorded live in our lovely little studio in downtown Ngaruawahia. The Big Smoke in Aotearoa, New Zealand, a place where Kiwis live in a paradise we like to call God's own country. A place where they put folic acid in the bread just to give you that vitamin B12 boost. Don't forget your periodic naps. Good night. Cheers. Thanks, Moz. And, well, let's see what happens. Good night and good gardening to you all. Cheers. See you.